Good morning. This is the e-learning video for Math 1 covering the distance. So here we're going to talk about how to find the distance between 2 points. First, we're looking at examples where the 2 points are graphed and a straight line is drawn in between 2 points. So we're basically trying to find the length of this line. And finding the length of this line is finding the distance between those 2 points. So one thing you can do is to do this, is create a right triangle. So we talked about in class, the right triangle has a right angle, and one way you can get a right angle is by drawing a horizontal and a vertical line. So then we created a right triangle where this line segment AB is the hypotenuse. Right? Here's my right angle, where the hypotenuse is the side directly opposite of the right angle. Now, one of the reasons why we want to do this is because it allows us to use Pythagorean theorem. Remember, the Pythagorean theorem is one that helps you with the sides of a right triangle. Right? Remember, it's that a squared plus b squared equals c squared formula. Right? Where we talked about the c represents the length of the hypotenuse. Right? So this side right here, we're going to call it our c side. Right? And our a and b sides are the sides that we drew in. Right? So this side, we can see, is 3 units long. So we know the length of that side. This side, we count it, 1, 2, 3, 4, 5, 6, 7, 8, is 8 units long. Right, so we can use these numbers for our Pythagorean theorem. Right, we plug 8 in for A, square it, 3 in for B, square it, and that leaves us with solving for C. Right, so take that calculator, we get 8 squared is 64. 3 squared is 9. Add these together, we get 73. C squared. But we're solving for C, so we need to take the square root of both sides. So C is equal to the square root of 73. And so there's the length of AB, or the distance between A and B. Okay. Do that again with example number 2. So we're trying to find the length of this line, basically finding the distance between these 2 points. Again, I'll just randomly label them A and B. Right, so for this, we want to again create the right triangle. So I'm going to draw in 2 sides, vertical and horizontal side, to create the right angle. So here's my right angle right in here. So this is my hypotenuse. So again, that's going to be our C side for our Pythagorean theorem. And we're using the Pythagorean theorem to help us find the distance between these 2 points A and B. This side has a length of 2. 1, 2, 3, 4, 5, 6, 7. This side has a length of 7. So we plug those right into our formula. So that's 7 squared plus 2 squared equals C squared. And using our calculator, end up with c is equal to the square root of 53. Okay, so now what I want you guys to make sure you're doing is that if you go to your calculator, like I go to my calculator here, and I take the square root of 53, right, and I see that it ends up to be a decimal. Okay, so I want you guys to go ahead and leave it as a square root of 53, unless the directions tell you to give a decimal answer. Alright, so again, if it's not a perfect square, like for example, if I took the square root of 25, okay, so square root of 25 is 5, so right, we want to go ahead and simplify that. But again, if it doesn't simplify, square root doesn't go to a nice perfect number, leave it as a square root. Okay. Alright, I'm going to give you some time here to work on number 3. Alright, so go ahead and pause the video right now and see what you get for number 3. Alright, so this is what you should have gotten for number 3. Again, you're drawing in your vertical and horizontal sides, making your right angle to make a right triangle so that you can use the Pythagorean theorem to find the length of side C, which again is the distance between the 2 points. Okay, so you get the square root of 45. Alright, so now we're going to move on to examples where we're trying to find a distance between 2 points, but you don't have a graph grid. They are not graphed on the graph grid. Right? So we don't want to say, well, let me create a graph grid, graph these points, and use Pythagorean theorem. Alright, we want to use another method in finding the distance between these 2 points. Okay, and that method is using a formula. Right? There is a distance formula. Okay, to find the distance between 2 points. This is the formula. You're going to take x1 minus x2, square it, plus y1 minus y2 squared. And all of that is underneath one big giant square root. Okay, so this is the formula we're going to use for these last 3 problems where we're trying to find the distance in between 2 points. Okay, so now you notice that in the formula we have x's and y's. Right, so where those are going to come from, they're going to come from your 2 points that you're trying to find the distance in between. Alright, so it's kind of similar to what we did for the slope formula, where we want to go ahead and label these points so you know exactly where they go into our formula. So now again, it doesn't matter which one you label x1, y1, x2, y2, just label the points. Alright, so I'm going to go ahead and label this one x1, y1, and this one x2, y2. Right, so and each ordered pair has an x and a y. And this will be my point 1, and this will be my point 2. Alright, so now with those numbers labeled, right, we can go ahead and plug them into this distance formula. Right, to find the distance, it's going to take x1 minus x2. So my x1 is negative 7, minus x2 is 0. Put into parentheses and square it. Plus y1 minus y2 in parentheses, so it's going to be 4 minus 3 times squared. Alright, so again, I'm just plugging in the numbers that were labeled accordingly into the formula, and let's not forget all of this is under one big giant square root. Okay. Alright, so again, this is where we want to make sure we're using our calculator to help us. Alright, so I want to go ahead and put parentheses. Let's do that here. Alright, so in parentheses, I'm going to do negative 7 minus 0. Close the parentheses. Then we're going to square it. Plus 4 minus 3 in parentheses. Square that. So just go ahead and press enter. We get 50. But so right now we have the square root of 50. And so 50 is not a perfect square. So that's again, if we take the square root of 50 right now, we press enter, we get a decimal. Okay. So again, you're okay to go ahead and leave it as a square root of 50. Or some of you remember how to simplify radicals. Right, you want to find the biggest perfect square that goes into 50. So we can break that up. Right, 25 times 2. So I'm breaking up square root of 50 as 25 times 2. Split up that way. So then we get square root of 25 is 5. Square root of 2 is not a perfect square. So here is the distance between those 2 points. Alright, so let's try that again with example number 5. Again, we are given 2 points that we want to find the distance in between, and they're not graphed, so we want to use the distance formula. Alright, so I'm going to go ahead and label this x1, y1, x2, y2. Alright, so plugging into the distance formula, we get d is equal to x1. So now, you gotta be careful, right? So it's x1 minus x2. So x2 is a negative number. So that's why we need to be careful. So it's going to be 3 minus negative 7. And then we're going to square it. Plus y1 minus y2 squared. And all of that underneath the square root. Calculator here. So in parentheses, I'm going to do 3 minus parentheses negative 7. Square it. Plus 2 minus 0 parentheses squared. Press enter. Get 104. So I get square root of 104. Right, so let's check and see. And I think we know the answer to this is that 104 is not a perfect square. Alright, but we can simplify that by breaking it up. Alright, let's see, 104 divided by 4. Does that work? Yep. Okay, so I'm going to break up 104 as 4 times 26, where 4 is a perfect square. So d is equal to the square root of 4 times the square root of 26. Square root of 4 is 2, and the square root of 26 stays 2 square root of 26. Alright? Alright, so I'm going to pause the video. I want you to pause the video right now, and then I want you to see what you can do with number 6. Alright, so here we go. So hopefully you labeled your points, x1, y1, x2, y2. Plug those into the distance formula. Again, this is the distance formula. Right here. Alright, so you plug in the distance formula, plug that all into your calculator, and we get a square root of 29 as the distance between these 2 points. Okay? Alright, so again, if you guys have any questions, please let me know. You guys have a great day.